Hi, everyone. I hope you had a great lunch. So let's get started. This talk is about augmenting empathy. And what I mean by that is basically that you already have empathy, but there can be some things or some tools that you can use to actually augment that a little bit more, to understand some situations and to make things a little bit more clear. So we'll be using CSS, SVG, and WebRTC to do this. So let's see. My name is Shwetank. I work as Accessibility Innovation and Research, head of it at Barrier Break. Basically what this means is I do a lot of R&D to try to look at new technologies and using existing technologies in new ways to basically help people with disabilities. I'm also co-editor of the HTML spec at the WCC and a few other W3C groups. Previously, I used to work at Opera. At Barrier Break, it's a company based in Mumbai, and it does a lot of work in consulting, accessibility consulting, auditing, and stuff like that. But it's also an enterprise with a social mission. And part of that mission is providing opportunities to people with disabilities, and so much so that about 70% of our staff are people with disabilities. One of those people in the staff is a person named Amit. He was born with low vision, and we got to get to know each other when I joined Barrier Break. And back in about 2005, he met with an accident, and he lost sight in his right eye. So, but that didn't stop him. He still had an interest in tech, and he ended up becoming a trainer and goes to a lot of different conferences, trainings, and workshops to actually teach people how to make their sites accessible. Now, when I got to know him, and we got talking, I quickly realized that there were a lot of things which people who didn't have low vision were confused about, especially with his condition, because a lot of times people just couldn't understand the way in which his vision worked or didn't work. Barrier Break also had a lot of other people who were low vision, so I talked with them as well. And at certain times, I talked with their colleagues, some of them, their friends and their families, and caretakers as well. And one trend basically kept coming again and again, which was a lot of times it was very difficult for people with low vision to really articulate what their condition was, how they basically saw the world. And sometimes people who didn't have low vision just couldn't understand what was happening. So I did a little bit more research. I actually consulted an ophthalmologist as well to get a medical perspective and a perspective of a person who has dealt with hundreds, if not thousands, of such cases. And one thing was very, very clear. Low vision is a very generic term, right? So if you say, oh, someone has low vision, a lot of times people assume that it's just a severe form of myopia, or a severe form of short-sightedness. That can be the case. But that's not always the case. Sometimes you have glaucoma, retinitis pigmentosa, macular degeneration. All these things are there. And if you ask the random person on the street, okay, what's macular degeneration, they might not know. So one thing became clear that one of the things that I could do is not to help people with low vision, but actually help everyone else understand what low vision is. And that's where the simulators come in. So I said, okay, can we make something to simulate what their vision is like? And if it is possible, can we use the web to do this? And also, gravy on top, if we can use JavaScript less and SVG and CSS more, then that will be even more awesome. So the first condition that I chose was colorblindness. And this is even more of poignant over here in Europe, because about 8% of men and about 0.5% of women of Northern European ancestry have some form of red-green color blindness. And it's you know, in the more you talk to people who have red-green color blindness, the more you'll see that in the physical world, or not just in the online world, but in the physical world, there's still a lot of stuff in which you need to determine whether something is red or green. Right? The most obvious example is traffic lights, but that's just not the case. There are other small cases as well. For example, if you have the MacBook charger, right? If you charge it, and if you want to look from afar whether it's still charging or it has a charge, the only way to distinguish it is whether it's red or green in color. That's it. So I made a tool which you can actually simulate different conditions. This is just using WebRTC and then applying SVG on top. And the reason why it's actually pretty useful is because a lot of times people get it wrong. If you ask, I've asked a lot of people who have just everyday normal 20/20 vision, what it would be like if someone has red-green color blindness and sees something which is red in color, what would they see? And a lot of times people become kind of confused, they don't know. A lot of times people just assume that it'll be like a desaturated version of that image, but that's not the case. Over here, we can see that in one condition, for anomaly, you'll have this bench as brown in color. On the other hand, you'll have something which is like greenish in color. The real color is actually red, right? So how do we actually do this? I use something called FE Color Matrix, SVG FE Color Matrix. FE stands for filter effects, and the color matrix is basically a set of matrix values that you provide. So it basically works like this. So you have an image. Each and every image will have an RGBA value. Now, you have a matrix with a set of values over here, and all you do is matrix multiply all those values together to form a new color for that particular pixel. You can define an SVG color filter over here, color matrix filter. So you can just say in the SVG, you can say filter ID is equal to whatever, and then FE color matrix, type is equal to matrix, and values, you can write out all the values, comma separated. In the CSS, it's as simple as saying filter URL, hashtag, whatever. So that's all very, very nice to know, right? But it's one thing to have an academic or mathematical perspective of how SVG color matrix works, and the other is to have an intuitive understanding. And the only thing that I've seen which grants you that is experimentation, unfortunately. You just can't get it, how it works just by learning a few things. You need to experiment. Fortunately, if you can just Google, you have SVG Filter Playground. It's a very, very nice resource where you can mix and match different values and see what the output would be. And that gives a better perspective and a more intuitive understanding of FE Color Matrix. I'll be sharing these slides later on as well with links to some really, really nice articles on FE Color Matrix. So let's take this opportunity to know about FE Color Matrix and put it in our pocket. We'll revisit this later on. So now that we have a tool which can address different color blindness conditions, one of the things that I also realized when talking with people with red-green color blindness is, well, how do you distinguish between red and green and nothing else? It's a bit difficult to do so. So I made something which, for lack of a better name, I just called the red-green color sieve. On the left, you have the one example of a Ishihara test, which is generally a set of tests which is used by people to diagnose color blindness. So if you don't have color blindness, for example, over here, you'll see something like 74. But if you do have color blindness, you might see something like 21. So over here, let me just go back. So over here, you can see that I've made something where you're basically isolating things into two categories. If something is red, it goes into the left category. If something is if something is green, then it goes into the other category. This is all done in real time, and it's all done using basically CSS and SVG. The only JavaScript part is actually getting the camera output. So this is how we do it. The first thing that we do is apply a SVG filter. And the second thing we do is apply a mixed blend mode of hue. Very simple, but it hides a lot of complexity behind it. And let's revisit this. Let's see and go into a deeper dive into what this all means and how this effect is actually done. So to do that, let's go really, really back. How many people watched Looney Tunes when they were a child? Everyone. Wow, everyone. So all these kind of cartoons actually use something called cell animation. Cell stood for cellulose, celluloid. And the reason why is because these were basically transparent sheets. And generally speaking, in any kind of animation, you had a bunch of characters which were moving around. but you also had some background which was static, right? So what you could do is basically have a sheet where you just paint the background once and be done with it, and then all the other stuff you can just do with the character animations and put one layer on top. So a lot of these animations were done like this, where the character animations were done by one team, and then the background animation or background painting was done by some other team in parallel, and then the final result was basically just putting those layers on top of each other. So this was basically an early form of what we call compositing. So compositing and blending, there's a spec for it as well. The CSS blend mode spec is based off this. But compositing and blending has been there for a long, long time, even as part of SVG. So what exactly is compositing? It's basically how to deal with overlapping objects, right? So overall compositing is Porter-Duff compositing plus blending. But what exactly is Porter-Duff compositing? It's named after Thomas Porter and Tom Duff, who in the early 80s, I think 1984, they published a seminal paper on how to deal with overlapping objects, this exact thing called compositing. At that time, they were, in the early 80s, they were working together on a small company called Lucasfilm, which was doing a lot of pioneering work when it came to digital graphics. And basically, what they said was in that paper that if you have two layers, one on top of the other, right? So the top layer is called the source layer, the bottom layer is called the destination, right? So in that overlapped portion, you can do pretty much four things. First, none. You don't do anything. You don't show anything over there. Second is the source, in which you show the top layer. Third is the destination, in which you show the bottom layer. And the fourth and more interesting one is show a combination of both the top and the bottom layer, right? And this is where opacity and alpha channels come in. So coming back to our example, what we need to do in the first half to recreate the effect that we saw in the color sieve is to somehow make it black and white, but only the red color showing. So in this case, what we do is, if you can see, the red, green, and blue channels are all 0, right? So in effect, what this matrix is doing is basically taking this image and making everything transparent, except for the colors which have a little bit of an R value. Then we composite it on top of the original image to get some of the red stuff. Then what we do is we take another image, and over here we're doing FE color matrix, type is equal to saturate, value is equal to 0, so it's totally desaturated. And then we composite them on top to get the black and white image with just the red showing. All of this using just SVG, nothing else. So now the first part is complete. The second thing we want to do is to understand blending and how that works. So blending is basically how to deal with the overlapped portion in terms of colors and the mixing of the colors. So for example, you have this particular layer, and then you have a layer on top of it over here. So there's a portion which is overlapping, right? How do we deal with the colors over here, right? That's the essence of blending. So in a more practical example, let's see this image, and if you want to recreate this image, we can have a few layers. We can mix and match them through whatever blend mode that we want to achieve this particular final layer. So this is essentially what blending is, mixing and matching different layers to achieve a final effect. So let's come back to our example. Over here, we have a container div, which is red in color. Inside this, we have the video, which is running. Right now, we haven't really applied any effect, so it's just the normal colors. The moment we apply a SVG filter that we talked about, everything is grayscale apart from the red stuff. Then we'll apply a blend mode. In this case, what we're doing is applying a hue blend mode. This works in the HSL space. So what it will do is it'll take the hue from the top layer and combine it with the saturation and luminosity of the bottom layer. So in this case, all of the black and white stuff will just be basically a whole big gray area, whereas the red stuff will be just very bright red. So ultimately, you get this, right? So it's just two lines, but it hides a lot of complexity. But it's very, very important to know the concept of layers and how it plays into blending and compositing, and what all you can do without just JavaScript if you just have a proper understanding of it. One more thing that I worked on was macular degeneration. Sometimes it's also called age-related macular degeneration, and often results in blurred or no vision in the central field. It's very hard to sometimes explain this, but if you have a visual, then you'll see what it actually means. It's sometimes also pretty tragic or heartbreaking because a lot of times it affects people who are older, and by the time they have grandchildren, and sometimes they have very hard time actually seeing the faces of their grandchildren. And that's something which, if someone else comes in, that's something which people don't get, the human aspect of how it makes people feel. So anyways, like I was saying, if I have to recreate this effect using CSS and SVG, or just SVG, or just CSS, how do I do this? Fortunately, in this case, I don't even want to use SVG. I can just use a radial gradient with a blend mode. And the way I do it is based on this. So if you have a container div, which is a radial gradient, which is basically just black to transparent, and you combine it with the video output, and then you apply a mixed blend mode or multiply, you get this kind of effect, right? In most cases, in most web designs, you won't really want to use this, but if you take the opposite of it, in which you have transparent to black radial gradient, and you combine it with an image, then apply a multiply blend mode, then you can get some really nice effects on images without using Photoshop, which is really, really great. One more thing that I wanted for all these simulators to do is for you to actually put it on top of VR headsets. Nowadays, VR headsets are getting cheap, and some of these actually allow for you to use the back camera to see on the other side. Not all of them, but some of them actually allow you to do that. So if you do, then you can actually do this. You can have stereoscopic mode, where basically you're having two video elements, and then you can also go full screen and use it as part of a VR to get a more immersive experience. Now the thing is, if you want to do this, right, there are a few things that you want to do. First, you want to make sure that it displays just one video on portrait mode and two videos on landscape mode. So you have to first detect whether something is in portrait mode and hide the video. There's a lot of stuff which is going on over here. I also want to make sure that everything is full screen so that you don't see the browser address bar. And once you're actually in that full screen mode, you don't want to switch between portrait and landscape every time you're moving your head. So you want to lock the orientation as well. So this is how we do it. You can have a full screen API. The moment something goes in full screen, you can use the orientation lock API to lock the orientation so that it doesn't switch between portrait and landscape all the time. One more thing that I do is I use CSS exclusively for full screen as well. So in this case, I can use, along with prefixes, of course, the full screen pseudo element. This will just be applied on full screen. One more thing that I do is, of course, have custom CSS for the orientation. So if something is in portrait mode, it needs to have a certain set of styles applied. And if something is in landscape mode, it needs something different. And over here, you can have the media queries for orientation landscape as well. Another thing that I've seen that not a lot of people are talking about, but they should, is the fact that in PWAs, you have a lot of display modes, right? So you can load a PWA as a normal browser tab, right? But once you install that PWA, you can open it up as a normal standalone app, right? And in that case, what happens is you don't have the browser address bar, which means suddenly you now have increased screen real estate that you need to account for, that you need to do something with, right? And over here, you can use the display mode standalone, or just basically just see what the display mode is, and depending upon that, you can have custom CSS to account for that. That's also one of the things that I've used. And one last thing that I'll leave you with is that none of this actually matters if you don't actually talk with people and interact with people with real disabilities. That's really, really important. I like this tweet, which says, I want to see something. Retweet if you're disabled and being told you're an inspiration, and the person told you didn't stick around to get to know you as a person, which is really true. It got like 630 retweets by the time I screenshotted this. And yeah, that's a big thing. Like when you're talking about empathy, you really need to generate empathy somehow, and the only way in which you can do it is to actually be someone's friend or actually be listening to a person, not just academically viewing things here and there, right? And that's one of the things about disability simulators. A lot of people think that just because I have interacted with a simulator, suddenly I know everything about people with that particular disability. That's not true. Human interaction is always required. A lot of times, people who are able-bodied, they put on a simulator, they struggle, and then they put it back down, and then they think that everyone with that disability is just struggling 24/7. That's also wrong. This is a tweet which says, not every person with a disability feels they're suffering. Some people are, yes, but the insinuation that disability is equal to suffering is a harmful ableist expression of able normative thought, which is true, right? So when it comes to empathy, one layer is, yes, you need to think about what other people are finding challenging, what problems people are facing, but the other side is actually to get to know what they want to do, what their potential is, what they aim for, what are their goals in life, and then what are you going to do about it, right? So these tools that I try to make, I always kind of force the idea that, okay, now actually do a task 5 times, because by the 5th time, they're not struggling so much. Then they realize that, okay, people who have these conditions have developed coping mechanisms and have actually kind of gotten used to it, and now they can just function just like everyone else. So being empathetic, it's, according to me, recognizing a few things. It's multi-layered, right? You need to recognize the challenges that people face, right? And it could be something as simple as just believing someone when they say they have a problem, right? And it just doesn't even apply to people with disabilities, but every kind of marginalized group. Just listen and believe them when they say they have a problem. The second thing is recognizing the strengths and the potential that people have, right? So if a person really wants to do something, have faith in them. I can give you a story of a person who is working in Maribek right now, who, when she was diagnosed with low vision, a lot of well-meaning well-wishers just said that, okay, take up pottery or take up handicrafts and stuff like that. It was coming from a good place, but it wasn't the right advice. That person wanted to go in tech. That person wanted to do stuff with computers. Fortunately, she joined Maribek, and now she's one of the top people over there. But the main thing is to recognize that what other people are supposed to be doing, what other people are capable of doing, and supporting that. And ultimately, the way in which you display your empathy has to be a combination of all these things. Just like blend modes, just like you have different layers and you kind of like mix and match between different colors, the same thing has to be happening with your approach towards empathying as well. So recognize the challenges they face, recognize that they are capable, they have potential, and then ultimately your action as well, because empathy without action is useless. And that's the thought that I'll leave you with. Thank you so much.